Hey everybody, it's me, Miss B or Miss D, and I'm going to be doing a quick video explaining your review for tomorrow's assessment, and then I'm going to be going over your 2 homework assignments from Monday night, Tuesday night, and Wednesday night. So let's get started. So you have 2 triangles. I'm going to call them triangle 1 and triangle 2. Triangle 1 is triangle A, B, D, and triangle 2 is triangle CBD. And something happened from triangle 1 to triangle 2. So the first thing says, is CBD a reflection of ABD across line BD? And that's correct, because A flipped over to the other side and became C by flipping over this line. So that is a yes. I don't know why I wrote no. Next thing says CBD is a rotation of ABD about point B. If there was a rotation, then point A should be somewhere around here. And because it didn't wind up here, the second one is not true. And then CBD is a translation of ABD. If this was a translation, then the triangle would still be facing this way. It's not. It was flipped over to the other side. So this is a no. CBD is a dilation of ABD. Dilation means that it gets bigger or smaller, and it didn't get bigger or smaller, so that's a no. And then CBD is this triangle, is congruent to ABD. That's true. And that's because, remember, rigid transformations do not change size or shape. Okay, how do I know it was a rigid transformation? Because it said it right here. So now we're going to use this picture to come up with our equivalent statement. So what I'm going to do first is, before I do anything, I'm just going to write my equal angles, because that helps me come up with everything. And then I'm going to write my sides. Remember, this is only for rigid transformations. This does not work if it's not rigid. Okay, so once I wrote these, it'll help me fill in the blank. So the first thing says angle ABD, that's basically angle B, has to be congruent to CBD. I'm going to use the same order that was written up here. Next one, angle A, well, look at what I wrote, is equal to angle C. Angle AB, I look what I wrote. So AB, bottom to the top, is equal to CB. And then DA, so from the middle to the left, is the same thing as the middle to the right, so DC. So that's how you come up with those answers. And now you can use this order to help you with these questions. So ADB, so if I look at this order, ADB should be the same as CDB. Is that what's written there? Yep. Next one says DAB, so DAB should be the same as DCB. Is that what's written there? Yep. Next one, BDA, so BDA should be the same as BDC. Is that what's written there? Yep. DAB, DAB. DAB should be the same as DCB. Is that what's written there? Is that CB? Nope. This is a no. And the last one, BDA should be the same as BDC. BDA, BDC, that doesn't work. So no. All right, so make sure you guys know how to do your congruency statement. So that's half of your assessment tomorrow. Now the next half has to do with what comes next. So what four postulates and theorems can you use anytime to prove two triangles are congruent? We have side, angle, side, 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 angle, side, angle, and angle, angle, side. Those are the four that you can use all the time. And they said, which theorem specifically applies to right triangles? We only had one that was for right triangles, and that's HL. And then they said, which two postulates or theorems should you be careful not to use? AAA never works. And SSA, or if you want to write the bad word, I'm going to write $ so I don't look like I'm cussing. That never works. So if that comes out, you would have to say, no, they are not. So the sentence is, no triangles are congruent if these two happen. All right, so it says write a congruent statement. So first thing I'm going to do is label my tick marks with S's. Every time you have an intersection, make sure you label that intersection with curves to look like a bow tie, and we're going to label those curves as angles. So now when you look from left to right, it's side, angle, side. So the postulate or theorem is side, angle, side. The congruent statement is the triangles. So triangle QRP, so QRP is congruent to, so Q looks like it's the same as T. R, of course, is the same as R. And P looks like the same as S. So you would say triangle QRP is congruent to triangle TRS by SAS. That is 2 points tomorrow. All right, next one. Anytime you see a degree, put a curve. And of course, anytime you see a tick mark, that's an S. And those curves that I just drew, that's an A. So it says, decide whether each pair of triangles can be congruent. If so, which postulate or theorem you use. If no, explain why. So I was able to use ASA. So I would say triangle ABC is congruent to, well, A looks like it's the same as D. And B looks like it's the same as E, so DEF by ASA. That's all you have to write if it's true. Okay, the next one, remember if I have an intersection, I do my little bow tie. And then that's about it. I don't really have enough information. When we get to the next topic, you will see that there are things we could do, but there's not enough information. So you would say no triangles are congruent. And this is where we explain why. Because there is not enough information to prove they are congruent. Now next week we're going to learn about the fact that we could make these equal to each other, but that's still the angle, angle, angle rule, and that still doesn't work. All right, we got a couple more. Here we have S, then the curves give me an A, and then anytime you have something that's shared, we can call that an S. That's the S line. So if I read it from left to right, that's S-A-S or S-A-S. So triangle MQN is congruent to, looks like M looks like P, Q looks like N, and then I guess That would stay the same. And we say by SAS. So if it's true, it's easy to write your statement. If it's not true, you have to write a because. Okay, last one. This is a right angle, so we put an A for angle. This is a tick mark, so we put an S. And remember, we have an intersection, so we're going to make our bow tie. And our bow tie becomes an A. So you cannot use HL because you don't have an L to do HL, so you got to use the other 4 rules. So if I read this from left to right, I have AAS. Or if you read it on this side, it's SAA. Remember, SAA is the same as AAS. So we could say that triangle GRE is congruent to G looks like T, R looks like M, E stays the same by AAS. All right, last one. They gave you some information, but you're missing some. So here they want SSS to work for here. So in order for SSS to happen, I need these 2 sides to be equal to each other, and I need this side. So I would need DF to be congruent to, looks like GJ, and I would need EF to be congruent to HJ. Those 2 things need to happen for this to be SSS. Now they said, what do I need for it to be HL? So I would need this to be my H, and then either one of those sides. So you could say, oh no, you could just use the side that was given. So all you would need for HL is DF to be congruent to GJ, because they already gave you that. That's the leg. All right, that concludes the review. I hope you enjoyed that in all 12 minutes.